Alright YouTube, today I'm going to do some work on a power supply. I built this in 1992. It's a 17 volt at 5 amp power supply, but lately I've been trying to squeeze 7 amps out of it. So this is for my high voltage generator that I built back in the early 90s. If I can get this beefed up a little bit, I'll probably put another video of my high voltage generator on. It took a fall onto the concrete a couple months ago. I am no machine shop here by any means, but you kind of see what happened there. Bent the hell out of the front face. This voltage control pod is a 10-turn precision. It's a Clarostat, and it busted the knob right off of this. The pod itself looks like it's unscathed. This box came from a power supply to a C-band satellite dish. If you remember the old 8-10 foot C-band satellite dishes, they had an actuator on the side of them. It was basically, the dish kind of pivoted, and there was an actuator, a long arm on the side of the satellite dish. And as that arm went in and out, the satellite dish would change its angle. And I'm not sure why I'm telling you this, but I just am because it's part of the story. But anyway, this transformer was in this box to power that actuator. Basically, it's probably like a 3-foot arm with a motor on the bottom of it and a bunch of gears inside it. So as you push the buttons, it swung the satellite dish one way or another. There'd be a worm gear in there to spin the arm out on the dish. Originally, I remember this had a big cutout up here where there was a LCD display in there to tell you what satellite you were on. So I wanted to repurpose the box and use it for this because it was kind of a heavy-duty box. So I put another piece of aluminum over the front face of it to cover up all the holes, and then just re-drilled all my holes in it to suit my need. So it's actually got double plates, plate on the back, plate on the front. So I think what I'm going to do is just pull this plate off, try to give it a couple good whacks with something, see if I can flatten that down. So this uses a really simple voltage regulator. I remember at the time I didn't want to put integrated circuits or anything like that into this. I wanted it to be bare bones, because when you got 150 kilovolts of DC that's zinging around the room, you never know when something's just going to short out on you. So it's 2 transistors. There's a pass transistor here on the back, which is probably like a 3055 or something. And it's kind of funny because this is something that, I wouldn't do today, but I mean, I put a big ass AC muffin fan on there on one single transistor to cool it down. So when you turn this thing on, it sounds like a jet turbine running, just to blow the heat off of one transistor. But the transistor gets smoking hot because really one transistor wasn't enough for this. Now there's another transistor down in here, which is it's a TI tip 152, I think. That would be an NPN Darlington. That one transistor down there shifts the base of this pass transistor up and down in order to regulate the voltage output. There's virtually nothing to it. They do kind of the same thing in these CB base station power supplies. They're very crude. The voltage regulation is not tight on them, but they're pretty much indestructible. So this thing has been beat around and ran for like 32 years now, and it's never had an issue. Even after the fall, it still works. This switch here bent the hell out of it, but the funny thing is, this switch still works. It didn't break anything in the switch. So again, that's 1992's parts right there, because that's a C and K switch. They are the Calvin Klein of all switches. I just got to get the bend out of it. I think what I'm going to have to do is just, unfortunately, scrap a lot of stuff out of here. I took the rectifier out of it here just recently for another project, so it needs a rectifier in it. And like I said, it would run like it is, but I mean, that's a hell of a bend there. One day later, and I tore everything apart, put some new wires on this board up here, which has two Darlington transistors and a 12-volt voltage regulator, so the brightness on these lamps here in the front stays consistent when you're turning the voltage up and down on it. It's a bit better than what it was. So I put Big Blue on it here. I used to have a spinner knob on this. Spinner knobs are really cool. They got the little crank on them, and you crank them around. That's a Radio Shack part there. Radio Shack sure had some cool stuff. Coming out of the back of it is a big hogging piece of SOJ cord. Or I'm sorry, this is SOW cord. It's 16.4. And this is the umbilical cord to my high voltage generator. The high voltage generator has an umbilical cord coming out of it too, and then you just connect these two lines together. I really should have like a 3-phase plug to give me enough connections on here, and just plug the two together. This wire here has that insulation on it that kind of like gets like chewing gum over time. Certain oils will break this stuff down too. So it's some form of rubber, because certain rubbers and oil just don't go well together at all. I didn't even put a hold down on that cable there. It goes in and makes a bend, so it's not likely it's ever going to pull out of there. The heart of the whole operation is this high-speed muffin fan. If that high-speed muffin fan wasn't on there, this thing would probably run for about 60 seconds, and this transistor would go into thermal runaway. I mean, this was never intended to really put out 5 amps, and then I squeezed another 2 out of it. This board here actually wasn't even made for this box. This is something I repurposed out of something else to kludge in there just to make this power supply for the high voltage generator. Because you can see there's rectifiers down here on the board. This was something that I built to be a standalone power supply, where you could just simply hook the transformer to these barrier strips. So I have a 100-volt rectifier in there. The voltage coming out of the secondary of this Houston satellite transformer is pretty high. That 100-volt rectifier should be fine. That's really all I could find. Now I'm kind of speculating this is probably a 10 or 12 amp transformer. Looks like it was made in 1984, so that would be kind of the height of C-band and satellite for TV, I think. I think the wires on the secondary here are going to be just long enough to connect to that rectifier. It was kind of my plan over the past, I don't know, like 30 some years to build a bigger high voltage generator. It was always in the back of my mind, but it never happened. Some of the reasons for that would have been the cost of building another one. I didn't know if that day would ever come, but now just quite recently, within the past couple weeks here, I found out that that day will never come. Because sadly, the guy who started the company, he was basically the heart and soul and brain and mastermind and everything else of what used to be called Information Unlimited, which started back in 1973. The guy's name was Bob Iannini, and he was a pretty glorious guy. He held a lot of patents. I got the privilege of speaking with him on the phone back in probably like 1992 or something. Anyway, I found out last year he passed away. So Information Unlimited shut their doors. There is no more high voltage parts. Bob had the market cornered, so to speak, on high voltage components. He was pretty much a genius. He knew what to get, what worked, what didn't. So those high voltage diodes, which are 15 kV at like 100 milliamps, are a thing of the past. That's kind of a really sad thing. It's even more sad that Bob Iannini passed away. I always knew the company as Information Unlimited, but at some point in time in later years, they kind of like changed their name or something. I don't know what they did. They come up with that Amazing One or something. The website was called. Bob was a sheer genius. I think that'll work. Beautiful. It's better than probably what it was to start with. Should be just about ready to plug this thing in and check the voltage on it and put a load on it. I'm sure everything's still fine. The only thing that could have possibly got damaged would be this voltage control pot, but I did check it out a little bit and it looks like it's okay. I think it is a little on the loose side. You can still hear her spinning pretty good. We got the neutral on there, that goes to the fan, that goes to there, that goes to the power switch, that goes to the line. This might be an issue over here. Yep, that's a little bit of an issue. Probably gonna have to put something on the side cover, piece of plastic sheet or something. It's running 3/16 of an inch off the inside cover, but it was kind of that way before and it lasted for 30 some years, so can't imagine anything bad's gonna happen in the next 30 some years. Three volts on the bottom. Goes up to 18. Oh, that's a bit too much. I got a 7 amp fuse in it, so great. Well, maybe not. My high voltage light isn't coming on. That one's coming on. Oh, you know what? I bet that's an LED in there. I bet that's not an incandescent bulb. The wires are on backwards. Yep, shoot. Oh well. Just flip the wires on the high voltage light and everything will be good to go. And at some point in time, I should be able to power up my high voltage generator, depending upon what the weather really does, what the relative humidity is. One more thing too, we should have something close to 36 volts here. We do 35. This is the voltage that runs the fan in the bottom of my high voltage generator. I am curious though how much that voltage drops off. Yeah, it's dropping a good bit under load. That's okay, it really doesn't matter. There's a dropping resistor on the fan in the high voltage generator underneath. And I'm sure I calculated the dropping resistor to coincide with the amount of voltage that's on that wire. Cool. Hey, I appreciate you taking the time to watch my video. You take care and have a great day.